Hello everyone, in this video we're going to solve exercise 12. The problem is asking us to find a transfer function for the circuit shown below. We're going to use KVL or Kirchoff voltage law or mesh analysis. The KVL is telling us that through any loop the voltage drop is zero. So through any loop the voltage drop is zero. So I have a loop here. I'm going to assume that's the direction of the current. It really doesn't matter as long as we are consistent. So I'm going to start here. So I have E1. I go through this resistor. When we are going in the direction of the current, we are losing voltage. So here would be negative RIT. First I write it in time domain and then I will take a Laplace to go to Laplace domain. And then I will go through this. I'm going from positive side to the negative side. So I will lose voltage here again. It would be negative E2. Then I go through this. If you remember, we had negative 1C. This is the Ohm's law, I dt, the integral of that. And then I will go here. I have negative L di over dt. That's the derivative equals 0. If I take a Laplace of the equation above, I will have E1 minus R is, t is changed to s, minus E2. The integral will give me s in the denominator minus 1 cs is minus ls. The derivative will give me an s. Is equals 0. Rearrange it. E1 minus E2. Take everything to the other side. I will have R plus 1 over CS plus L S is. Transfer function is output over input. What is output for us here? Can you tell? Which one is output, which one is input? Or the output is the current that we are getting. We are putting the voltage in hope of getting a current. We have two source here, so that would be is E1 minus E2. That gives us CS or CS plus LCS squared plus 1. Looking at this transfer function, can you tell me the order? We have S squared, so that's the second order, simply because we have both C and L. One is S in the denominator, one is in the numerator. When we rearrange everything, we would get the second order. If we had one of them, not both, we would have dealt with the first order system.